This video is going to be about the law of cosines. The law of cosines, as you see here in the center of the page, actually has three different representations. The little a's, b's, and c's mean the same thing as in the law of sines. They are the side opposite the angle with the corresponding big letter. So little a is across from angle A. Now, it may look overwhelming that there are three different equations, but it's important to notice they're actually the same thing. They all start with one side, and it equals the sum of the squares of the other sides minus 2 times the other sides times the cosine of the angle across from the original side. You'll notice they all have that same pattern. That when you start with b squared, it's the cosine of b. When you start with c squared, it's the cosine of c. So you really aren't learning three different formulas. It's just three different representations of the same formula.
Law of cosines.
So let's look at a first example. Here you'll see that we know two sides of this triangle and one angle, and we are looking for the third side. Again, it's not a right triangle, so we can't use SOHCAHTOA. We also can't use the law of sines because we're not in a side-side angle situation or an angle-angle-side situation. We're actually in a side-angle-side. So we're going to need to use the law of cosines. So let's start by labeling our sides. Again, it really doesn't matter which angles I make what letter. Let's get a better color. As long as I make sure that across from angle A is little a, across from angle B is little b, and across from angle C is little c. Now, you may be wondering which of those three formulas should I use? Well, that all depends on how you labeled it. Based on how I labeled the triangle, we are looking for little b. You may have labeled it little a. It doesn't actually matter. But because we're looking for little b, I'm going to use the equation that starts with b squared, and then we have a squared plus c squared minus 2ac cosine b. You'll also notice this works out really well because the only angle we know is b, and this equation would be the only one that had angle B in it. So now I'll just replace my variables. So I know B is actually x, so I have x squared. Little a is 7, so 7 squared. Little c is 11, so plus 11 squared. Minus 2 times 7 times 11. I'm running out of space, but times the cosine of 50. Now the calculator is going to be really useful here. But I'm going to point out one really common mistake that I always see. You want to make sure you follow PEMDAS. This whole part at the end needs to be done before you subtract it from whatever you get up here. Do not fall into the trap of doing 7 squared plus 11 squared minus 2 times 7 times 11 and then multiplying by the cosine of 50. I see it all the time. So we can go to the calculator, but you're going to end up with x squared equals 49, which is 7 squared, plus 121, which is 11 squared. And then we're going to be subtracting 154 times the cosine of 50. I'm now going to go to the calculator and do most of the next steps in there. The cosine of 50 is 0.64, so here I have replaced cosine of 50 with that. I've now done this multiplication over here, again following PEMDAS. And now I've just added and subtracted all of these numbers, leaving me with x squared equals 71.44. We're not done though. You need to make sure you take the square root of both sides, leaving us with x equal to 8.45. And now you're all done. Here we have a second example. This time, instead of looking for a side length, we're going to be looking for an angle. You'll notice in this case we have a side, side, side situation, which is another time when you're going to use the law of cosines. Now here they've actually already labeled the triangle for us, which is great. We have angle A, angle B, and angle C. Doesn't actually matter, but I'll make sure I put in little c, little b, and little a. Now, this time to decide which formula to use or which equation to use, you'll notice I'm looking for angle B. That means I probably want to use the equation that has an angle B in it, which would be the one that starts with b squared and ends with cosine of b. I've now put the equation in, and now I'm just going to replace each of my variables with the numbers I know. B squared is going to be 37.83 squared. That equals 68.01 squared plus 42.15 squared. And then I subtract off 2 times 68.01 times 42.15 all times the cosine of b. And remember, I don't know b, so that's just going to stay as that. I forgot the square there. I've now used the calculator to simplify 37.83 squared, 68.01 squared, and 42.15 squared. I've also combined the 2 times 68.01 times 42.15 right here and left my cosine of b. In this step, I combined these two numbers together, I added them together to get 6,401.98. Notice I did not subtract the 5,733 because that is multiplied with the cosine. So following PEMDAS, I can't do anything until I multiply it with cosine of b. I now have no choice but to subtract from both sides. And then my final step will be to divide by 5733.24, which will leave me with cosine of b all alone. I'm now left with cosine of b equaling 0.867. Please remember, you now need to use the inverse cosine to solve for your angle. And I now get that my angle B equals approximately 30 degrees. I apologize for some nasty numbers in there, but hopefully you were able to follow the process. Let's quickly talk about when we use the law of cosines. First of all, we definitely only want to use it because it's kind of nasty, so we only want to use it with non-right triangles. Once we've determined it's a non-right triangle, so we can't use SOHCAHTOA, we then will use it when we have a situation of a side, included angle, and then another side, or a situation where we have all three sides and we're looking for an angle. My biggest advice is basically use it when the law of sines doesn't work, because I find the law of sines a lot easier. So for homework, I'd like you to do these two problems. In number 1, you're going to be looking for side C. And in number 2, I'd like you to find angle A. Good luck.